All right, let's jump right into this explainer. Today, we're going to do a cosmic zoom out, and honestly, it's probably going to completely break your sense of reality about the space we live in. You know, we usually just picture space as this map of distant stars and planets, but today, we're looking at it differently. We're going on a journey of escalating distance, measuring not just how far things are, but how profoundly isolated we truly are out there.
Because the crucial point we're exploring today is that distance in the universe isn't just about empty space. It's a journey into extreme isolation. Literally, the second you step past our immediate neighborhood and head for the stars, all of our human logic of measurement just totally collapses. You stop measuring in kilometers, and you start measuring in solitude.
So stage one, our fragile cosmic neighborhood. We're looking at the moon and the sun.
We're starting at mile marker 0, where the numbers still hold at least a little flicker of human familiarity. Let's start with the moon. It sits 384,000 kilometers away. Now sure, that sounds massive, but it is actually laughably small compared to the grand void we're about to enter. Honestly, it's the only thing in the universe that feels even remotely close to us.
Just to put that into perspective, if you could jump in your car right now and drive straight up at 100 kilometers per hour, it would take you about 160 days to hit that gray surface. But for light, the absolute fastest thing in the universe, it crosses that exact same gap in a mere 1.25 seconds.
And here's a fact that's absolutely going to change how you look at the night sky. If you took every single other planet in our solar system, the gargantuan Jupiter, Saturn with all its rings, frozen Neptune, and line them up side by side, they would perfectly fit into that gap between the Earth and the Moon, with room to spare. It just completely reveals that our grand planetary neighborhood is in reality just a handful of marbles compared to what's coming.
Now that 1.25 seconds for light to reach the moon, that's what created that famous 2.5-second radio delay for the Apollo astronauts. But watch what happens as we look further out to our sun, which is about 149 million kilometers away. Light takes 8 minutes and 20 seconds to cross that distance, which means we are always, literally always, living in a delayed past. If the sun vanished right this second, we wouldn't even know for over 8 minutes. We're just happily relying on an 8-minute-old ghost of a massive nuclear reactor to keep us warm.
Moving on to stage 2, crossing the Great Divide, the Oort Cloud and Voyager 1.
So we're stepping off the sidewalk of our solar system and into the true abyss. You know, if you ask someone where the solar system ends, they'll probably say Pluto. But Pluto is just the edge of the driveway. The true edge is the Oort Cloud. It's this gargantuan spherical shell encasing us, basically a dark, freezing crystal ball full of icy monoliths. Out here, stretching out to 1.5 light years away, sunlight is just a dim flicker, and the temperatures plunge to absolute zero.
Now think about what we've actually sent out into this dark territory. The fastest object humanity has ever built, Voyager 1, has been flying out there for nearly 50 years. Yet compared to the tech we have today, it's astonishingly primitive. I mean, it has 3 million times less memory than the smartphone sitting in your pocket right now. It transmits data slower than an 80s fax machine, and it's drifting out there on barely enough power to run a couple of light bulbs. It's basically a fragile message in a bottle. And here's a milestone that will really make you pause. By late 2026, Voyager 1 will be so profoundly isolated that a faint greeting from Earth, traveling at the literal speed of light, will take an entire day and night, 24 full hours just to reach it. And then we'd have to wait another 24 hours just to hear a tiny whisper back.
Which brings us to stage 3, islands in the dark, Proxima Centauri and the Milky Way.
This is where we see that human flesh was just never designed to cross these chasms. Take our closest neighboring star, Proxima Centauri. It sits over 40 trillion kilometers away. When you look up at it, you're actually seeing a 4-year-old ghost. We used to romanticize this place as a potential second home, but the reality, it's brutal. It's this furious monster star unleashing deadly radiation, and at Voyager 1's current speed, it would take us 73,000 years to reach it. Even if we used our most futuristic laser-push nanosails, it would still take decades.
To really grasp our place in the galaxy, imagine that staggering, impossible distance to Proxima Centauri was just the size of your city. On that scale, our Milky Way would be 20,000 times larger than that, yet we don't live in the vibrant downtown core or even the desolate outskirts. We basically live in a quiet suburb. We're in an ordinary arm spiraling 26,000 light-years away, safely distant from the catastrophic, life-ending energy of the supermassive black hole right at the galactic center.
We're essentially trapped in this dusty, gaseous disk that's spinning at 800,000 kilometers an hour. But because the scale is so staggering, it still takes 225 million years just to complete a single lap. Just think about that for a second. Since the dinosaurs went extinct, our planet hasn't even finished a third of a single galactic orbit.
All right, stage 4, the Great Cosmic Migration. Andromeda and Laniakea.
As the scale completely shatters our human comprehension here, we shift from static distances to terrifying movements. Andromeda is the most distant object you can see with the naked eye. But the light hitting your retina tonight, that is a 2.5 million-year-old news report. When those exact photons began their journey, modern humans didn't even exist yet. Our ancestors were still banging rocks together to make primitive tools. Right now, Andromeda is just a faint smudge on our window, but it's hurtling right toward us at 110 kilometers per second. It's on a crash course for an inevitable collision in about 4.5 billion years.
100,000. That is the massive number of galaxies inside the Laniakea Supercluster. If the Milky Way is just our suburb, Laniakea is the entire continent we inhabit. At this scale, we aren't just specks of dust in a galaxy, we are tiny, microscopic grains of sand drifting on a magnificent cosmic river of light that stretches 520 million light-years across. Now, in Hawaiian, Laniakea beautifully translates to immeasurable heaven. But here is the most haunting fact about it. You aren't standing still. You, me, our planet, our entire galaxy, we're all part of a grand, chilling migration. We're drifting alongside 100,000 other galaxies at hundreds of kilometers per second toward this invisible, totally mysterious gravitational abyss we call the Great Attractor.
And that brings us to stage 5, the ultimate eternal emptiness, the Boötes Void and the final edge.
Prepare yourselves, because for our fifth and final stage, the voice of the universe drops into absolute, terrifying silence. Imagine treading water in a pitch-black ocean, where you travel for millions of years in any direction and find absolutely no ripple, no star, no island, nothing. This is the Boötes Void. If the entire Milky Way, with its hundreds of billions of stars, were just a single grain of sand, this void would be a vast, pitch-black, entirely empty warehouse. It spans a mind-bending 330 million light-years.
According to the standard laws of physics, this space should be absolutely teeming with about 2,000 galaxies. But instead, there are only 60. Just 60 severed, lonely embers trapped in profound darkness. They are so incredibly isolated from everything else that their light has to travel for hundreds of millions of years just to find a companion. It's a riddle that completely defies physics. It is the very definition of oblivion.
46.5 billion light-years. That massive number is the radius of our observable universe. But remember, space doesn't just stand still. Because the very fabric of space is constantly inflating, kind of like a stretching balloon, the ancient light we're capturing with our telescopes today is really just a ghost from a much smaller, much denser past.
And that brings us to the most terrifying boundary of them all, the cosmic event horizon. Sitting roughly 16 billion light-years away, this is a boundary where dark energy is actually pushing galaxies away from us faster than the speed of light, which means any flash of light emitted beyond that line today will never, ever reach Earth. Because of this, trillions of years from now, future civilizations are going to look up into the night sky and see absolutely nothing but pure blackness. They'll be completely unaware of the Big Bang or any other galaxies. They will honestly think their lonely galaxy is all that exists in the entire universe.
Which leaves us with this final, profound thought. The universe isn't just unimaginably vast. It is actively closing its doors on us. Every distant star we see right now is an invitation, sure, but it's also a quiet goodbye. So, as we wrap up this explainer, I want to leave you with this question to ponder. When the eternal dark finally conquers the distance and swallows the last of the light, what will remain? Thanks so much for joining me on this incredible cosmic journey. Keep wondering, and as always, keep looking up.